Hi, g'day, Mr. Hanna here. Welcome back to Math Methods Unit 1 and 2. In this video we're going to be looking at linear modelling. So this is using linear equations to actually solve real life sort of problems. And just a quick heads up, this is the sort of stuff that you're going to be expected to do in the SACs. So pay lots of attention and make sure you complete lots of these questions as practice. So in this video I'm just going to be doing two questions that are approached in a slightly different way. So let's check out question 1. A home phone line, antique things that they are, a home phone line costs 25 cents per call plus $10 per month line rental. And you're asked, A, write a function that describes the cost of the home phone every month. Okay, so what they're really looking for, write a function, so they're looking for some sort of function. So remember, functions are like the f of x equals something or other in terms of x, maybe plus or minus something or other, look like that, every month. Okay, so we need to come up with some symbols. So instead of using f, let's use something like this. C dollars that can be their cost. Call it C dollars. And what's the other thing that happens here? The cost depends on per call. It depends on how many calls you make. So let's call n the number of calls. Number of calls. Okay, so our function will be, it'll be like this, the cost, and it depends on n. So C of n, cost of n. It's like this, f of x, except here we've got C for cost and n for number of calls instead of x. So cost, depending on number of calls, is equal to. Alright, so how much do we pay each month? Well, every month we pay 25 cents per call. So that is 25 cents times the number of calls. So 25 cents, because here it's in dollars, so we need 25 cents is $0.25 times the number of calls, plus $10 a month for line rental, so plus $10. Okay, so our cost depends on the number of calls, and our cost every month is 25 cents times the number of calls, plus $10 for the line rental. Okay, so that's part A done. We have written a function and it describes the cost of the home phone every month. So that is our part A done. Part B, how much would it cost if you made 100 calls in a month? So we're looking for how much does it cost. So we want to know what is C for making 100 calls. So N is 100, what is C? So it is going to be done like this. Cost of 100 calls is 0.25 times 100 plus 10. 0.25 times 100 is 25 plus 10. That must be 35. And remember our dollar sign, because the question's asking how much would it cost. So it's going to cost $35. It doesn't just cost 35, it costs $35. There we go. And part C, how many calls can you make? So we want to know what is the number of calls. How many calls can you make if you only want to spend $15 every month? So what is N? N is question mark for the cost of N being only $15. So we want the cost to be $15 and we don't know what N is. So we'll write this down. So instead of just a cost of N from our equation, we're writing $15 there. So 15 is equal to 0.25 N plus 10. And we've got to solve this equation. So first we'll subtract 10 from both sides, getting 5 is equal to 0.25 N. And now we've got to do, where am I? Okay, so now to find n, we divide by 0.25. 5. How many 0.25s? Alrighty, so we know that we could do this on a quick calculator if you wanted to, or we know that if it was 1, how many 0.25s, the answer would be 4. So it's going to be 5. So in other words, it's 5 times 1. How many 0.25s? 0.25 is a quarter, so that's going to be the same as 5 times 4, which equals 20. Now you've got to write the actual answer. So you could say 20 calls costs $15, because that's what the question asked you for. So you need to write your answer. Okay, so bit of a tip, always write your answer at the end. Your answer in words at the end. There you go. Always write your answer in words at the end of each part of the question. So that's kind of similar to making sure that we have the dollar symbol on for 35. Okay, so there we go. That's that whole question. Now, the hard bit is to interpret. The hardest bit is interpreting these questions in terms of what they want you to do in maths language. So like part A, you had to know that it was going to be a Cn equals something n plus something. Once you had that, it's pretty easy. Similarly, for part B, you needed to be able to say n is 100, C is question mark, and you had to find out C of n. And part C, you had to do the opposite. You had to know that C of n is 15 and n is question mark. So this, if you can go from the words to these three statements, that is by far the hardest part. So you should always do that. Before you start part A, you should try and write out what you're trying to do. Before you start part B, you should write out what you're trying to do. For part C, you should write out what you're trying to do. So there's a few tips. All right, let's use those tips to check out question 2. So here we go, question 2. The tyres on a racing car had lost 3 millimeters of tread after completing 250 kilometers of a race, and they'd lost 4 millimeters of tread after 1,000 kilometers. Assuming that the loss of tread is proportional to the distance covered, what that means is the loss of tread proportional to the distance covered. That means linear. We're talking a linear equation here. Find the total loss of tread, d millimeters, after x kilometers of a race. So this is asking us for an equation. We want the loss of tread after a certain number of kilometers of race. So it's going to be like this. Tread in terms of distance is equal to something amount of times distance plus or maybe minus some number. Okay, so let's try and figure this out. By the way, let's think about it just using our minds for a second. Oh, actually, no, we won't. Okay, so it's a bit hard to just find our equation without a bit of a sketch of our situation. So another tip, sketch a graph. Sketch a graph if you're able. Okay, a graph will help you make sense of the situation. So let's quickly sketch one. We know that this is going to be x, which is in kilometers, because from our graph, from our equation, we know that x is the dependent variable and d is the independent. So up on this axis, we'll have our distance. Oh, sorry, that's d is actually for tread, isn't it? In millimeters. Tread. Okay, so we have 2 points. There's this 3 millimeters of tread after 250 kilometers. So we have this point that is a 250 kilometers, 3 millimeters. So make sure you get these around the right way. The kilometers one's the x one, so it needs to come first. And our second point is 4 millimeters after 1,000. Whoops, I've just done exactly what I told you not to do. I've got them around the wrong way. Remember, the tread is the Y and distance is X. So hopefully you picked up on that little error. So it's actually 1,000 for 4. So let's write these things down. So we've got, let's make this 250, 500, 750, 1,000. So this will have to be 3, 4. So 3 millimeters of tread here, 4 millimeters. Let's actually make this axis. Let's do one of these, which means it's not proportional, and let's put 4 up here. Okay, so 3 is there, and 4 millimeters of tread. There we go. Whoops. Whoop, that's supposed to be straight through those 2 points. Okay, so use a ruler for that bit. Okay, so there's a bit of a graph which is going to help make sense of this. So remember, when we're going from a graph to an equation, we've got to do 2 things. We've got to find the gradient and then sub in a point. So I'll just jot that down, find M, and then sub a point. Okay, so first let's start with finding the gradient. So the change in Y from 4 to 3 is a 1. Change in X is from 1,000 to 250. Which is going to be 1 on 750 is the gradient. So now we need to sub in a point. So let's write out what we know so far. D of X is equal to 1 on 750 X plus a constant C. So let's sub in this point here. Alright, so we have D of X is now 3, which equals 250. So 250 equals 1 on 750. We're subbing it in. X is 3 plus C. So we have 250 equals 3 on 750 plus C. Now 3 on 750 is also 250. Oh gosh, I've done something very stupid. Okay, pause everyone. I've done a horrible error. This line here, I've done a horrible error. I've accidentally swapped these 2 things around. So I probably won't bother editing this video because I think it's helpful for you to see that mistakes are so easy. So let me just get rid of all this and swap around those 2 bits. Why's my eraser not working here? Oh gosh, that was an embarrassing error. So we actually have D of 250 equals 3. That's, whoa. It equals 3. That's much better. So we actually have 3 equals 1 on 750 times 250 plus C. So 3 equals 250 on 750 plus C. Now 250 on 750 is actually a third. So 3 equals 1/3 plus C. So C is equal to 3, take away a third, where 3 is actually just 9 over 3 minus a third, which is equal to 8 over 3. So our full equation looks like this. our distance tread for every kilometre is 1 on 750x plus 8 over 3. There we go, that's question 1. Oh, no it isn't question. Oh yes it is. So we read our question again. The total loss of tread, d millimetres after x kilometres of the race. There it is. D amount of tread in terms of x is 1 over 750x plus 8 over 3. Okay, so there's A, fully done. A bit annoying that one was. And the hardest part was making sure we didn't accidentally swap, like I accidentally did at one point, swap our D with our X. Okay, that is the easiest mistake to make, I think. Okie dokie. Next up, part B. We're asked how much tread would be lost after 2,000 kilometers. So here, X is distance, so that is 2,000 kilometers. And we're asked how much tread will be lost. What is D of 2,000 kilometers? We need to find that out. So we'll use our equation. D of 2,000 equals 1 over 750 times 2,000 plus 8 thirds. So 2,000 over 750 is the same as 200 over 75 plus 8 thirds. And I'm just going to cheat with a calculator here. Okay, so let's cheat with a calculator. So we had 200 over 75 plus our 8 on 3. We got 16 on 3. Done. And our answer is in millimeters of tread. Whoops. So there we go, there's the full answer. Hopefully you found that helpful. Get some good practice in, and I'll see you later.